Okay, so we're recording now Zoom session 4 over the second half of module 3. Normal distribution, page 16. Any questions? Page 17. The mean and the standard deviation reflect the location and the shape of the normal distribution. Page 17. Page 18. Probability is area under a curve. And the normal curve that we deal with primarily, I shouldn't say primarily, but to a large extent, the standard normal curve. Any questions with page 18? Page 19, actually getting into some problems using the standard normal curve, really using table 1, finding areas under the curve. Any questions here? You may think, well, why are we doing this? There's no data here. What's the statistics with all this? This normal distribution and even the binomial distribution, I like to think of them as tools that will be used in order to do statistical inference when we get into modules 4, 5, 6, and 7. And statistical inference is the main focus for this course, but module 3 is important because it gives some tools to address statistical inference. But anyway, so that's, let's see, that was page 19. Any questions with 19, 20, page 20? Okay, I want y'all to be comfortable with this notation Z with the subscript alpha. We're going to use that throughout the semester. So Z sub 0.10 is a particular Z value that has 10% of the area under the curve to the right of it, 90% to the left of it. It's 1.28. Z sub 0.10 is the 90th percentile. Questions with page 20.
Dr. Riggs?
Yes.
I just had, I guess, in the homework and then trying to do the stuff on page 20 with the Z subscript alpha.
Yes.
I was just having trouble using the chart, and I guess like it kind of feels like we're working backwards, you know, to get the percentile. And I just was having trouble doing that.
That's exactly what you're doing. You're working backwards as compared to the process you use for page 19 problems.
Right.
Yeah, so I mean, that's the way to describe it. So if you wanted to find, so let's look at this one. If you wanted to find Z sub 0.10, that's finding the Z score that has a right area of 10% and a left area of 90%. Okay. And the reason I introduced the left area is because that's how this standard normal table, the standard normal table gives us areas under the curve to the left for corresponding Z scores.
Okay.
So, so I couch this problem in terms of a left area. So this Z sub 0.10 is a Z value that has a left area of 0.90. So I go to my table, and again, the middle, these values in the meat of the chart are the areas under the curve to the left of the Z score. So I want to find the area that's closest to 0.90. And if you look at this first part of table 1, all these areas, in fact, they're all less than a half.
Right.
And then when we get to, because these deal with the Z scores that are less than 0. But when we get to the second part of table 1, all these areas are greater than a half because they deal with Z scores to the right of 0. But I want to find an area of 0.90. And you notice these values are increasing here, so 0.8907, 0.898, 0.8997, 0.9015. Now, the true value of z sub 0.10 is really somewhere between 1.28 and 1.29. But for us and our purposes, if we just find the z-score that has a left area that's closest to what the question's after, that's good enough.
Okay.
So this number here, 8997, that's closest to 0.90. So the z-score that corresponds to that is 1.2, and then this tells me the hundredth digit associated with the z-score. So this is 1.20, this is 1.21, 1.22. I want to go all the way over to where this was. This z-score is 1.28. So the z value that fits this picture is 1.28. Another way to think of this z value is it's the 90th percentile of the standard normal distribution. Does that help?
It does. And I may be getting a little bit ahead of myself here. But then I was doing a problem today. I can't remember if it was in the book or the homework, where you multiply the z value by 100 or by the standard deviation and the mean.
Yeah. There's situations where maybe you're finding a percentile on a normal distribution that was not standard normal.
Okay.
And you have to find you do use yes. I mean,
It's like working backwards to standardize it.
Yeah, you're working through. I mean, y'all see that Word file there? Okay.
Yes.
All right. Let's see if I can. So using this relationship, z equals, x minus mu over sigma. That probably the problem you're referring to. You were wanting to find a particular value of x that fit a certain situation or a particular x percentile, and so you solve for x in this expression here. And when you do that, if you just do the algebra, when you solve for x, you'll see that x equals, you multiply both sides by sigma first, and so you'll have z times sigma, then plus mu there. I think that's what you're seeing. Anyway, we may get to that later down the road.
Okay.
Other questions with page 20? Questions with page 21. Here we kind of move from the standard normal to any normal distribution. So this page shows us the relationship between any normal and the standard normal. It's basically through this transformation, z equals x minus mu over sigma. Questions with page 21. This is a measure of relative position. When you standardize something, it tells you how many standard deviations a value is from its mean. Let's see here. So any questions at page 21? Page 22. Here we had an application. Where it's assumed that IQ scores follow a normal distribution. It's a non-standard normal distribution. The mean is 100 and the standard deviation is 16. So to find any probability about that distribution, we have to standardize it and then use table 1 from the book. So here, the 120 has been standardized. We get 1.25 area under the curve to the left of 120 on the distribution of X is the same as the area under the curve to the left of 1.25 on the distribution of Z. And we use the table to get 0.8944. But this problem basically it looks at finding probabilities, 1 and 2 do, for a non-standard normal distribution. And then this third part within this problem, number 3 there, deals with finding a particular percentile from this distribution. So it's kind of using the inverse that you mentioned earlier, or the working backwards idea as you mentioned earlier. And here you can see where I've got actually specifically the subscripts. This is the 98th percentile for the standard normal is going to equal the 98th percentile for this distribution of X minus the mean over sigma. Really what I wanted to do was find X to 0.02 or the 98th percentile of X 0.02. So I'm using algebra to solve for that. And it's mu plus Z times sigma. Plug in those values. Mu was 100, sigma was 16. This Z value I had to find from the table, and I set up a picture over here to help us find that. Questions with that example, 3, 2, or 1? Okay. Page 23 deals with basically assessing if a population is normally distributed or not. For us, this is, it plays a role for us because in a lot of the statistical methods that we're going to use later down in the course, we're going to assume that our population that we're sampling from is normal or approximately normal. And we need a way to check that assumption, okay? And so one way to check it is to look at a histogram and ask the question, does the histogram look close to bell shape? Well, that's kind of that particular technique is not that good if the data set is small, because histograms are kind of clunky when the data set is small, say it has 15 observations or 10 observations or even 25. Really the best way to do it is to use what's called this normal plot or this quantile plot. And here I described the procedure in here. Really for us, I'm going to let JMP construct this for us, and I might put a QQ plot on a test and say, hey, does this QQ plot indicate that the data comes from a normal population? Basically, you check to see if the QQ plot looks close to linear. I didn't show you specifically how to do this in JMP. Would y'all like to see it? Or maybe Google that later. You can. Maybe if we have some JMP questions at the end, we can get to those as well. Any questions with this page? 23, page 24, sampling distributions. So the idea here is basically we've taken a sample from some population, and we summarize that sample by taking X bar. All right, so we have a sample mean X bar, and the question here is, what is the distribution of X bar? First of all, the mean of X bar is the mean of the sample means, and the standard deviation of X bar is the standard deviation of the sample means. Those expressions, I've got them written down here with what that is, but those values are given right here, that the mean of those sample means is the population mean, and the standard deviation of the sample mean is the population standard deviation over the square root of n, or the square root of the sample size. And then this third bullet here, this is important. It says, well, what about the shape of the distribution of X bar? Well, this theorem here says that if we take a sample from a normal population, X bar is also normally distributed with this mean and this standard deviation. I'm using my cursor. I'm assuming y'all can see that. Is that right?
Yes.
Okay. So is it lagging too much, or is it?
No, it's good.
Okay. So this theorem tells us something about the shape of the distribution of X bar, and if we sample from a normal population. The central limit theorem is a powerful theorem. It looks at the distribution of X bar if we sample from any population. Okay, I didn't want to do that. If we sample from any population. The central limit theorem says that X bar is approximately normal with the same mean and standard deviation as before, but N has to be large. Okay, so that's really the only condition to get approximate normality for X bar by the central limit theorem. So this is going to play an important role for us in setting the basis to do statistical inference in Module 4, in particular when we are trying to do inference on a population mean. But it kind of fits into Module 3 because it deals with the distribution of X bar, which is normal or approximately normal. Anyway, so 25, questions with page 25. Okay, so I had an example there. I think I had a couple of examples in 25, or in this section here, and then also another example on page 26. Are there any questions here on page 26? One thing I want y'all to be aware of is that as the sample size gets large, the distribution starts to become more peaked and the variability tightens up around the mean. So this is the distribution of X bar when N is 106, and it's got a smaller standard deviation than the distribution of X bar when N is 30. So that's an important thing to be aware of. Questions with this page, 26 or 27?
Dr. Riggs, I have a question.
Yes.
So I think part of my problem where I'm getting kind of tripped up is I understand how to standardize and find Z and use the chart.
Okay.
But I think part of my problem is when I'm reading the questions, I'm not sure what formula to use, or for example, like on this page on 26, when they start using the P with X bar minus mu, that I'm not sure when I would bring that in versus standardizing something, or.
Okay.
So are there context clues in the words that or like in the problem that I could look for?
Well, are you okay with this first part, that this question, the setup is asking a question about a sample mean? It says, suppose we take a sample of size 30, what's the chance that the sample mean is less than or equal to 98.5? Are you okay with that? That's mathematically the probability that X bar is less than or equal to 98.5?
Yes.
Okay, good. Well, so you say, well, when would I use this instead of say just this?
Right.
Okay, good question. So really both of those are following under this thinking that if you want to standardize a variable, you take that variable, if I can spell it, and you subtract off the mean of the variable. I'm typing all that out to be very general, divided by the standard, I don't like the way, the standard deviation of the variable. Okay, that didn't come out very good at all. But maybe you get the gist of it. And let's see here. I write it that way because when you think about X bar, in this setting, X bar is my variable instead of just an X. And so if I want to go from X bar to Z, I take the variable, which is X bar, and subtract the mean of X bar, or the mean of the variable. Well, the mean of X bar, let's go back up here. What is the mean of X bar? The mean of X bar is just mu, the mean of the original population.
Okay.
Then I divide by all this jumble here is standard deviation of the variable. What's the standard deviation of X bar? Well, it's not just sigma. The standard deviation of X bar is actually this right here, sigma over root n. So when I down this problem here, right there, I've got the variable minus its mean divided by the standard deviation of X bar, which the standard deviation of X bar is sigma over root n.
So I can kind of assume that if I see n in a probability problem, that should be the formula that I should go to.
Well, I mean, that's I would call that a clue. I don't want to say it's an airtight clue that you're going to do this procedure. Really, the thing that what's going on here is we've taken a sample from this population, and we want to find the chance that we get a mean. Now, when it says that, because it's a sample of size 30, when it says mean here, it means, no pun intended, it means that it's a sample mean. What's the probability of getting a sample mean of 98.5 or lower? Now, the sample mean is, the symbol for that is X bar. And so I think if you get to this point first, you realize, hey, thereafter, I want to know the probability that X bar is less than or equal to 98.5. Then with this sort of thinking, okay, I've got to, in order to compute this probability, I know that X bar is approximately normal by the central limit theorem. And so I've got to standardize X bar to a Z to use the normal table. To standardize X bar, to standardize any variable, I'm going to do this transformation. I'm going to take the variable, subtract the mean of the variable, and then divide by the standard deviation of the variable. You know, I'll say this, the more of these you work, I think maybe the quicker and more clearly you'll be able to recognize when to use what formulas.
Okay.
I put practice problems on there. I just listed practice problems for you to look at and put videos associated with that. But your book has bukus of problems that you can work through. There's examples in there. And of course, there's problems in the exercise set that you can work that are not from homework and they're not practice problems. But you can work through those and maybe find some of those have the answers in the back of the book, so that might be a good place to start as well. And then if you're working on an extra problem and you got a question about it, you know, and you want to, feel free to ask me. I'll try to steer you down the right direction. Other questions with the end of this module? So I think I heard some crickets, but let's, module 3 completed. No more questions. Do we want to talk about some WebAssign problems?
Yes.
Okay. I will say, in case y'all haven't noticed, I posted some videos that address some of the WebAssign problems. So depending on what question you ask me tonight, I might reference that, or we'll see how it goes. But as you pick your WebAssign problem, I'm going to look at the problem from the book's perspective. It's just easier for me to work with in this book as opposed to WebAssign. So first problem, WebAssign, chapter 4 stuff. Trying to get to chapter 4 exercises. If you noticed on the WebAssign problems, it also has a sub, or has a number in a parentheses or after the WebAssign number that tells you it's an exercise number from this book. So if you got a WebAssign problem, let's reference that exercise number if you can see it. But anyway, all right, so who's got a question about a WebAssign problem? Maybe if you hadn't asked a question yet tonight.
Dr. Riggs, I'm looking at problem number 6, and I know that you addressed that with a video, but I'm still having trouble on part C.
Okay.
You had mentioned...
Now remind me, that's number 80 something, isn't it? It's number 86?
Yes, 86.
Okay, good.
So I'm struggling with, I followed you in the problem until you got to the point where you said we needed to break it down algebraically.
Okay.
It's been a long time since I've done anything with algebra, and I am at a loss as to what I do to find n.
Okay, fair enough. Well, the good news is, that kind of algebra, solving that equation for n is probably, in terms of algebra for this class, on the more difficult side. So don't despair thinking, oh, I've got to go rehash every algebra thing that I've ever learned. Remind me what, there was an equation. Maybe you can read the equation to me and we can kind of talk through solving it.
Okay, so I have it down to where we have the probability with z less than, do you just want that part?
Yeah, so the probability that z is less than
150 minus 160 over 20 divided by the square root of n.
Okay.
And that equals 0.01.
Okay. So, are you okay up to that point?
Yes, I'm fine up until that point, but I don't know what to do with that to find n. Okay.
Let me ask you this. If you think about this probability statement, really, this is, I'm trying to highlight this fraction. This ratio here, eventually I set that equal to a number. Do you see what number we set it equal to? Or maybe I just kind of guided you in that direction.
You mean that all equals because we're trying to find the how many measurements?
Right. So we want to find this n, and basically we're just ultimately trying to set up an equation that will let me get to n, to find n. This probability statement here, so you're okay up to this point. This thing that's highlighted in blue, if you, you know, I'll see if I can do this or not. This whole quantity, here, my writing pad is, I got to find another way to project it. I made all those videos using Zoom with my writing pad, but I'm recording this and we're having a meeting with Zoom, and I can't do 2 Zoom sessions. It won't let me. So a little slow with this. This whole thing right here, do you buy that is Z subscript 0.01?
Correct. Yes.
That whole, okay, good. So really, I need to figure out what is Z sub 0.01. Did you find that out? Or I can write it this way: Z sub 0.01 equals this ratio here. You're okay with this equation? How? Okay, good. So did you find Z sub 0.01?
In our book, on the chart?
Yes.
Let me see.
This is, you know, I want you to think this number is the 99th percentile of the Z distribution.
Mm-hmm.
So I'm going to, you go to your table there and you look for 0.99 in the meat of the chart. Let's see. Try to get as close to 0.99 as you can. I think this is the closest one, right?
Yes.
So that's a Z score of 2.33. So then this 99th percentile is 2.33. So I have 2.33 equals this stuff, really. Is that okay?
Yes.
Okay. So algebra-wise, this may be, what this n right here, this root n, it's actually in the denominator of the denominator. Okay. So if I could convince you, let's suppose I had 1 over 1 divided by 1/3. Okay, what is 1 divided by 1/3? Really, it can be kind of confusing. I've got this 3 here is in the denominator of the denominator. Really, if you think back to what is division. Division is multiplication times the reciprocal of the thing you're dividing by. So 1 divided by 1/3 is really 1 times, or let me use, let's see, I guess that's not a times symbol there, times the reciprocal of what I'm dividing by 1/3, so the reciprocal of 1/3 is going to be 3 over 1. So, and this right here, 1 times 3 over 1 is really just 3, right?
Yes.
Okay, so you want to think of 1 here, is 1 over 1, so you got 1 times 3 over 1 times 1, and that's just going to be 3 there. So with that principle in mind, really this number 3 was in the denominator of the denominator, which really just meant that it was in the numerator to begin with. Does that make, so this root n here, is really just up here in this numerator with the 150 minus 160. So I could write this equation now as 2.33 equals root n times 150 minus 160. And then all of that is divided by what? 20. Is that okay?
Yes.
Okay. So algebraically, we want to get n by itself. The thing that is clinging to n, if you want to think of it that way, is 1, this number. Let me go ahead and reduce that. That's negative 10, right?
Yes.
Okay. So that's negative 10. And can I go a little bit further here and reduce the negative 10 over the 20? So that would be 2.33 equals, let's see. So that would be root n in the numerator. And then in the denominator, I would have negative 2, right?
If you take negative,
simplifying the 10 over the 20. So far, so good.
okay, so if I take negative 10 and divide it by 20, I get, and maybe I'm not, I get like negative 0.5. I think I may not be doing that right.
Well, no, that's right. Look where this 2 is. It's in the denominator. So really, if you ignoring the root n in this fraction, this is really negative 1 over 2, or 1 over negative 2, which is negative 0.5.
Okay.
So I mean, if you didn't want to write it this way, you could delete this and write negative 0.5 times the square root of n if you wanted to. In fact, we can do that.
Yeah, because that makes more sense to, I mean, that makes more sense to me at this point.
Okay, so you simplify the numbers. So like that.
Okay.
So to get n by itself, I've got to contend with this negative 0.5. So I'm going to, negative 0.5 is being multiplied by root n. To undo negative 0.5, I need to divide both sides by negative 0.5. So I need to do the opposite operation that's holding negative 0.5 to root n. I need to do the opposite operation to get rid of it, to push it to the other side. And so that opposite operation would be, I'm going to divide both sides by negative 0.5. So if I do that to the right-hand side, I have to do it to the left-hand side. So in your calculator, what is 2.33 divided by negative 0.5?
Negative 4.66.
Negative 4.66, okay. And that now equals the right-hand side. I've got negative 0.5, and I divided by that same thing, so that canceled out, right?
Yes.
So all I have over here is the square root of n. And so now to get n by itself, I've solved for the square root of n, but I just want n. Well, think with me with in terms of radicals. Remember this kind of rule here. If I had, say, the square root of 3 and I squared it, remember what that would be? It would just be that number 3. If you have something that's square rooted and you square it, it's just that number. Or equivalently, if you had if you had the square root of 3 squared, or squared, that's also 3. So what I want to do to both sides of this equation here, to get n by itself, I'm going to square both sides. So if I square this right-hand side, I'm going to square the right-hand side. If I do that to the right-hand side, I got to do it to the left-hand side. So I'm going to square negative 4.66. And what is that squared? Roughly
21.72.
21.72?
Yes.
Okay. And that equals the square root of n squared is just n. So that's the same. Now think about that. Mathematically, that's the number that goes into this ratio that makes this probability 0.01. Okay. Well, what does that number represent? That's a sample size. That's a number of measurements, right? In this problem here, the number of measurements required to get the probability at 0.01 or smaller. And so I can't have a sample size. You know, you can't take 21.72 measurements. You can take 21 measurements or 22 measurements, but not 21.72. And so in order to make this conservative to where the probability is at most, you're going to increase the sample size from 21 point. You're going to round up effectively. So the number of measurements would be 22. Does that help?
Yes. When you do all that, it makes complete sense.
Good.
I would never have figured that out on my own.
Well, you know, that's this course is not a correspondence course where we just kind of give you the book and say, here, learn it, come back and take a test at the end of the semester. We're here to help, and it's not a course in algebra. Algebra is important, but again, this might be one of the more difficult algebraic equations that we'll work with in this class. Any follow-up questions to this problem or discussion from this problem? Okay, so that was 486. I think you said number 6 on WebAssign. Are there other WebAssign questions?
Another one that I have is number 7, which that is question 101.
Okay.
So I'm looking at part C on that one, where it's asking if the cholesterol levels are above 300, what % of adults in that age bracket could be expected to exceed 300? So I worked that just like I did A. That one was asking if it was greater than 250.
Right.
So I have got, the answer that I have is 0.0018. I cannot come up with anything else other than that. But when I put that in WebAssign as a fraction, I have put it in as 0%, 0.18%. I've rounded it to 0.2. Like it does, it's wrong. So I feel like I'm missing something.
Okay.
Oh, Latifa agrees.
Okay, so.
So I don't know if it's something, I'm frustrated.
Okay. Well, I I had someone that ran into, I think, a similar problem with what you had. So let's see here. So you have basically the probability that what variable did you use? Can we call it y?
Yeah, so I put, I computed it into the natural logarithm. So once you got that, I put y was greater than 5.70.
Okay. I think what's happening, so this is what we want, right? I think what's happening is you might be rounding too early. So if you punch this into your calculator, take it out, say to the 4 or 5 significant digits, or maybe more than that.
Well, actually, it's not 350, it's 300. Sorry.
Oh, 300. Okay.
So if I do
the natural
5.7037.
Okay, so that equals 5.703.
And if you round it, that's
8.
an 8. Correct. Yes. There you go.
Okay. So if we go that far out, now try to standardize it. So you would standardize it. You'd have y minus mu over sigma. That would be greater than 5.70378 minus, what's the mean? 5.35?
Correct. Yes, sir.
Okay. And then divide by the standard deviation, 0.12.
Mm-hmm.
All right. So this equals the probability, this y minus mu over sigma, that becomes z. And see if this number is different than what you were getting before.
Okay, so if I do that number, then I've got 2.948.
2.948. So now you say, well, why are you rounding here? So if I round at 2.95, and the reason I would do that is because the table on the z-scores only goes out to the 100th place. So, for me to write out 4818729, I don't, I won't, it's not going to help me any getting precision off that table. So what did you get when you just had 5.7 minus 5.35 over 0.12? Did you get something different than this?
Yes, I got 2.92.
Okay.
That makes, even if you take it out that far, because we're working with does it really percentage?
I'm having trouble hearing you. I think you said something. Why would we take it out that far?
Right. I said just because. I said, do we take that far because we're looking for something that's such a small percent? Yeah. Whenever you, that's one way to look at it. When you start to get real far out in the tail of the distribution, we need to be a little extra careful. I think probably what's making it that considerably different is dividing by this smaller number 0.12. I think that's throwing it a little bit. But so if you use the table, you get 1 minus what? 0.9984.
Which is 0.0016. And you were getting 0.0018, is that right?
Yes, sir.
Okay. So, yeah, on WebAssign, I know that can be kind of frustrating. It's kind of a artifact of these computer homework systems. I wish it maybe had a little more flexibility in it. I say that, but in terms of exams, if I noticed in your work you rounded this to 5.7 and you had 2.92 and you got 0.0018, you know, that would be fine. You'd get full credit for it. But, you know, this is just, I guess that's the system that is. So really the issue is just rounding, to make a long story short.
Okay, well, that makes sense now.
This is 300. I had that wrong the whole time. Other WebAssign questions?
Dr. Riggs, I'm having trouble with 5B, which is 80, it looks like.
Okay.
I got the first three correct. And then,
okay.
Let me try to find it. So I did Y, and then the squiggly line and the normal N. And then the mu was 125 and the standard deviation was 32.
Okay. So Y is distributed normal.
Yes.
With a mean of
125.
And standard deviation was
32.
Okay. And so what is Y specifically in this problem? The patient demand, is that right?
The distribution of the number of the patients requiring hospitalization during a week.
Okay. Okay. So let me just kind of ask you a practical question. Do y'all see why it would make sense to consider this as a random variable? I mean, from week to week, this thing, that patient demand is different.
Right.
Yeah. Sometimes I read an article the other day. They were talking about a hospital in Tyler that was, what's the word that was used? They basically were running out of hospital beds. They had a special name for it. I can't remember. But anyway, so this is an important sort of thing. So part B, if the facility was built with 160 patient capacity, what fraction of the weeks might the clinic be unable to handle the demand? And so here we're looking at the probability, basically, that the Y value would exceed the 160.
Where does the 185 come in?
The 185.
I'm sorry. So on 5B, it says if the facility was built with a 185 patient capacity, that's what mine says.
Okay. So, yeah. So WebAssign is randomizing this number evidently.
That's why it's red.
So, so when you work this, so it's got a different demand. That was a bigger hospital. So you would look at the probability that Y exceeds 185, and you would need to standardize Y So you standardize it in a similar way that we did up here. You subtract off the mean
Yeah.
of y and divide.
I think I
Okay.
did that, and then I tried to do something with 52 because that's how many weeks were in the year, and
Maybe
real
making it
crazy.
a little more difficult than it. Yeah. So 185 minus 125 over 32. Was that the standard deviation you had?
Yes,
Even?
sir.
That may have been different. Okay. So then so we okay up to this point. So this would be the probability that
Yes.
Z exceeds whatever that number is.
I got 1.875.
Okay, so 1.875. So I would round to 1.88.
Okay.
And then that should, you'll get a decimal and it'll say what fraction. You can say, well, what's 1.88? If we want to look, what is that value? 1.88, 9699. So 1 minus 0.9699 is going to be 0.0301.
Okay. And when do we know to use the 1 minus what we're, I guess, like the location of Z?
Okay. What I'm not doing here on the screen, but what I would highly recommend is that you draw the picture that represents this probability.
Right.
So draw the normal curve, and it's centered. Draw the standard normal curve. It's centered at 0, and then go over to 1.88. Mark that.
And we're looking for what's to the right of it?
Yeah, you're looking for what's to the right of it.
Okay.
And this table gives you areas in the curve to the left of the Z-score.
Oh, and that's why okay. Got it.
We subtract from 1. The total area is 1. So to get any right area from this table, we need to subtract the left area from 1.
Perfect. Okay, thank you. That makes so much sense.
Good. Yeah, these problems, I recommend that you draw the picture, draw the bell curve, and that usually will help you in deciphering, do you subtract from 1, whatever. I'm hesitant to give hard and fast rules on when you do that. Just draw the picture. What do you need? What does the table give you? And work from there.
Okay, great. Thank you.
Good. Other questions? Any other questions from WebAssign? Or any questions from the practice problems? Or just questions in general? I'll say this. This week I had several questions early in the week about WebAssign problems or practice problems, and I was able to address those. And for some of those questions, I went ahead and put a video on D2L that addressed that question from a particular student or set of students. And that's a good thing to do. If y'all ask me questions early in the week, then I can get a response to you early, middle, before the week gets here. I know the assignment's due on Sunday, but you know, after Friday afternoon, I'm kind of staying off of D2L really. So ask the questions early in the week, and I'll try to get back with you as soon as I can.
So Dr. Riggs, I just wanted to make a comment. So this is my first experience with like an online only math course. So I don't know exactly how you do this, but I appreciate the videos that you're putting on and the help that you're willing to give us with the homework. I mean, I don't know if that's above and beyond or that's something that you just do, but it really is very helpful. And I just want to let you know that that's appreciated, especially for those of us that it's been years. I think for many of us that we just, you know, I'm pulling this like from a course I took, I don't know, 12 or 13 years ago, maybe.
Yeah, no, yeah, I'm happy to help. And, you know, this class, if it wasn't online, we'd meet 3 hours a week. And, so it's reasonable for me. The course for the most part has already been created in terms of the lectures, and I know you could count that as part of those 3 hours, but it makes sense for me to answer questions and to put as much out there for y'all to help. I'm glad to do that. I will say, and I've mentioned it, and I'll throw it out there again. If y'all or anybody's interested in a private tutoring, I know of some graduate students in statistics that would be really good private tutors. They live in Nacogdoches, so I don't know how that would work out. But you know, I'm happy to help. As you have questions, ask them. I'll try to get responses as quickly as I can. If you wanted more of a one-on-one situation with a private tutor that you're with several nights a week or whatever, you know, I can try to connect you with somebody in that way. I've also, just to let y'all know, I've had a Zoom session with, you know, other students, just one-on-one during office hours, or if somebody wants to make an appointment, we can do that as well. I think an efficient way to answer questions is when y'all ask them by email, and I try to respond. And if we need a little more clarification, we can set up a Zoom session. You know, this time on Thursday evenings, I think is good. But throughout the week, you know, early on, ask questions, and I'm happy to help. So, any
question?
Hello?
Can you hear me?
Barely. Kind of a shaky audio.
Can you hear me?
Sort of. What? Maybe if you ask your question, I can hear it. I'm sorry, I'm not hearing anything. Maybe send a chat message if you have it. So Amber, your audio, when you say audio, your microphone isn't working, or you can't hear me. Okay. Does your speaker work okay? Okay, so question 4B. So question 4B, can you tell me why the answer is the 30% value? 4B, what is that reference? What exercise number is that? This one here? Okay, 72. So what score separates the top 60% from the bottom 40%? That's what I've got. So if we want to go with 70 and 30, we can. Let me move this here. So basically, you're asking the question. Let's see. This is number 72. Okay, so the College Boards is the variable, and it is said to follow a normal distribution. Those scores are with a mean of 500 and a standard deviation of 100. So here, Y is the score, and what we see is that Y is distributed normal with a mean of 500 and a standard deviation of, what was that, 100? Anyway, so if you want to draw a picture for this, I think it would really set it up well. It's saying what I want to find. So we let me say it this way. So let's find. Let's say K. K. Such that the probability that Y is less than K, that is equal to 0.3 . Am I reading that right? Let me make sure. It separates the top 70% from the you had the top 70% from the bottom 40%. So, or I'm sorry, yeah, the top 70% from the bottom 30%. So I think this is the setup you've got. You want to find what value on the distribution gives me this probability. And if you could draw a picture, let's see here. I've got my tablet. It's not working very well tonight. I'm going to try to draw that normal distribution.
I'm coming here. Is that okay, Mama?
Maybe you could take a bath. You go take a bath. Get ready.
Okay. Let's plug the iPad in.
So yes, a statistics tutoring session is entertainment for little kids. All right. So, if I can draw the distribution of y, it's taken a second to register. The mean here is 500. So what score separates the top 70% from the bottom 30%? Uh-oh, I think I got too many windows going here. I've got my K in the wrong place on the picture. I don't like this. Let's see. Okay, so this is kind of frustrating, this tablet situation. That is 0.3, and this is 0.7, those areas. Is that okay, Amber, that picture? What score separates this here is this is the top 70%. I'm shading the top 70%, and then the bottom 30% there. So we want to find that K. I'm gonna work with this screen now. I want to find that K that corresponds to this probability situation. So if you want to think about, actually, I'm going to bring the screen back. If you want to think about what this K value is a particular is a particular value of y. I'm scrapping this tablet. Really, could I not say find, when you think about the notation we've had so far, remember, let's look at this example. Back with the IQ scores, in this example here, we wanted this upper 98th percentile was x of 0.02. The value of x that had a right tail area of 0.02. For this problem, for the WebAssign problem, this value k, we could give it the similar kind of notation. We would use y though, lowercase y. The subscript would be the right area, the area under the curve to the right. And if you go back to this picture, if you can kind of tell, that area under the curve to the right is 0.7. So I would have y to 0.70. So really that k is, when I think about what is that k is the 30th percentile, or y to 0.70. In order to find y to 0.70, I've got to induce the standard normal distribution. I have to find the 30th percentile for the standard normal, and then use this relationship here that we used, z equals x minus mu over sigma, in order to get y to 0.70. So what I would work with next would be z subscript 0.70, and that would equal x subscript 0.70 minus, what was the mean of that? Or, I mean, y here. We've been using y. What's the mean of y? The mean of y is 500. So I'm going to subtract off 500 here. And the standard deviation of y is 100. So effectively, I want to now solve this equation for y to 0.70. Well, first thing I'm going to do is, actually, let's find out what this number is, z to 0.70. Amber, can you figure out what that is? Or anybody help her? Okay, good. So what was this number, just to kind of give some completeness to this? What was this z value here? .52. I think it should be negative. This value of z has a right area at 0.7 and a left area of 0.3. So if I went to the standard normal table and I look for a left area of 0.3, it's going to be over here with the negative z-scores. So left area 0.3. So here's 0.3085, 3015. This here looks to be the closest. Actually, no, this is the closest to 0.3. So there would be z is negative 0.52. Maybe that's what you meant to say. So this is negative 0.52 equals this expression here. And then you solve for that. So Amber, you got the right answer at that point. Okay, so we can call this problem complete. And that really about does our time. It's 8:30. If you have any other questions, specific questions, you know, email me those and I'll try to respond to those tomorrow. You can email me through my D2L. That's usually the best way to do it. Otherwise, if y'all have any questions, I hope you have a good weekend, and we will, Lord willing, meet next Thursday night again, and it'll be over Module 4 and also kind of with an eye towards Exam 1. So, all right. Well, y'all have a good night, and I will talk to you later.
Thank you.
You're welcome.
Thank you.
You're welcome.
Thank you, Dr. Riggs.
You bet. Now take care.